Hello, y'all. Well, the university ended up being closed all week, so we didn't get to have class on Wednesday. This is what we would have talked about. Transformations. This is assignment 9 from the WebAssign homework. And transformations, too many PreCalc students end up just memorizing something. I would like it if we could avoid doing that and instead had a better intuition of what is going on. So here I have an example for you. I have two parabolas drawn, just two generic functions. They might as well just be generic functions, but they look like parabolas. And they have, they're not moved in the y direction. They're not moved in the y direction. All that has happened, it would appear, is that this blue one shifted over, and instead of having its vertex at 0, we now have the vertex here at this other number. And the objective of transformations is to find what that should be, the question mark. What should the question mark be so that if I put the question mark into the function f, it would just be g. It would be the function g. Now, let's use some knowledge that we know about parabolas to kind of help us answer the question of what the question mark should be. We would know that this would be x squared. This would be x squared. Let me write it for you in a goofy way. X minus 0 squared. It's x minus 0 because now I can see that the root is 0 for this parabola. And I can see that the root for g of x would, is a. So this would be x minus a quantity squared. Because if I took the value a and put it right there, it would say a minus a, which is 0. And that would satisfy the property that it had its vertex at a, at the point a comma 0. Then it would stand to reason that all I should substitute into the function f is x minus a. If I put the value x minus a into the function x squared, then it would say x minus a quantity squared. And then now they're identical. So we have moved f of x. It is transformed into g of x by inputting f of x minus a instead of just f of x. That's a transformation. Now, the thing is we didn't explicitly need the definitions of the functions to get this done. I could have just still focused on this idea of like maintaining the same y value, because I know that the y values are still going to be the same and that only the x values would change, because look at who is being modified here. It's just the x value that's being modified. I'm subtracting a. That would be very different from f of x and then I subtract a. F of x is a y value, and so this would be taking the y value and modifying it. That would shift the graph up and down, not left and right. So, by the same idea, if this is some f of x, and this is some other function g of x, I can see that the x values aren't moving, it's just the y values that are moving. The g of x is the same thing as f of x, it just got slid down by, down to this point a. And so I'd be curious about how could I modify that y value so that it came out equal to this other function that was transformed. So I'm going to scoot f of x down by a units. Actually, if I want to say that, then this has to be minus a. If I want to scoot f of x down by minus a units, then minus a, so I scooted up. If I want to scoot f of x down by a many units, then this point right here has got to be minus a, and that's exactly what this number would be. It says take the old y values and take away a many units from those y values, and you get the new y values. And this is a transformation in the y direction because I am modifying those y values from what they were to be a new quantity. So over here, I'm modifying x values. Over here, I'm modifying y values. So this is, so I say all this just to illustrate the key observation for dealing with transformations. Clearly here I'm modifying the x value, so it's going to shift in the x direction. I can evaluate the function at that x value, x minus a, and it will be shifted over by a many units. And if you want to determine left and right, I do not encourage you to memorize anything with respect to this sign. Instead, I encourage you to draw a picture where you have, like, just like our first picture illustrated, where this is the value a and this is the value 0. Then you can see that if you put the a right here, you would get f of 0, and so evidently this would move the curve to the right by a many units. It's always going to be x minus, and then how far is it going to move to the right? A many units. If it winds up saying x plus a, well then that just says x minus negative a. So it would move to the right by negative a many units, which means it's moving to the left. And then, so this is a modification of the x values. However, if I start off with a y value and then modify it, then clearly I'm modifying the y values. This is a y value, and I'm moving it down by a many units. Okay, so let's look at some examples from the home. All right, so I accidentally already put the answer on this one because I was trying to make the video earlier and decided to re-record it. We're not given the function explicitly, we're just given, we're not given the function explicitly, we're just told that it is a function, f. And like I said, you can reason your way through this just by drawing a picture. If that's going to be the function f, if this is going to be f, and then and move it over. If this is f, and that right there is the value of x, and it's coming out that f of x is 0, then it must be the case that if I move the curve over to -1, then in order for me to produce an f of 0, which is a y value, I have to have f of x plus 1. Then you can take this -1 and put it right there, and it still says f of 0, which is the same y value. So it would move to the left by 1 unit. The next example is a modification of the y value. Right? F of x is a y value, and then it's plus 8, so all of the y values of the transformed curve are 8 more than they used to be. So it used to look like this, and now it looks like this, where this distance is 8. So it moves up by 8 units. Okay, so now they're talking about f of minus x. If we're talking about f of minus x, then all that's happening is we're attaching a minus symbol to the x values. So maybe I have a curve, maybe this right here is f of x, and perhaps that right there is, I don't know, a. The y values are not being modified, so it must be that if I look at f of minus a and put that curve there, and you substitute minus a into here, it says minus a negative a, which is just f of a. So it gives you the same y value. Then evidently all that's happened is there is just a reflection about the y-axis. Or you could say across the y-axis, but probably about a reflection about the y-axis. Four times f of x. That's modifying the y value. Whatever that y value was, it's now 4 times more. If it was a 1, well then now it's 4 times 1. So that's a vertical stretch. Minus f of x plus 2. Okay, all we've done is modify the y values. Look at the multiplication part first. Just study what it would be if it was minus f of x. A minus f of x says that if whatever the y value was before, now it's the negative version. So if it was 2, now it's negative 2. It is a reflection about the x-axis. So it's reflecting about the x-axis, and then the plus 2 just says to add 2 units to that y value. So it moves up by 2. It reflects about the y-axis and then moves up. I said y-axis, I didn't mean that. It reflects about the x-axis and then moves up 2 units. This says 6 times the old y value and then take away 2 units. So it's going to get stretched out vertically by a factor of 6 and then shifted down 2 units. Now we have a combination of both modifications to the x value and to the y value. So probably focus on the modification to the x value first, right? I would have to put a minus 9 in here for it to say 0. So however that curve was behaving when x was 0, the transformed version now mimics that behavior when x is minus 9. So it shifts to the left. It shifts to the left by 9 units. Okay, so it's not this one and not this one. It stretches it out to be 4 times, it's a 4 times vertical stretch. Okay, so it's not going to shrink, and then it's got to shift down by 1 unit, right? So this is our answer. I didn't mean to click that, sorry. Okay, and then here we have a transformation in the x direction. The function has to move over to it had to move over 5 units. However that function was behaving when x was 0, it will now mimic that behavior when x is 5. Because if I put a 5 right there, it says 5 minus 5, which is 0. So it shifts to the right by 5 units, so it won't be this one, and it won't be this one. And then you have, well, what an odd way to word it. I mean, when I multiply by a number here, it's always some kind of stretch. But if that number is less than 1, then technically that stretch is a shrink. So I'm not sure what they mean. Like, you could always just say it stretches vertically. And to me, you always could say that. But I'm fairly confident that they mean for you to say shrink. Because if we were going to get pedantic about it, I would say that if you chose to use the word shrink, then you would need to say it shrunk by a factor of 4, not 1/4. It's either going to stretch by 1/4 or it's going to shrink to be 4 times smaller. Because if I shrink by 1/4, then that means I'm 4 times bigger. But I don't think that they were thinking about that when they wrote the question. I'm fairly confident they mean for you to say that it shrinks vertically by a 1/4. We'll see. So they probably do not mean for you to say stretch here. And then it's going to shift up by 9 units, so it won't be this one. And so you're left only with the one option. Let's see if it takes it. I didn't answer part A, so it's going to, I guess, count it wrong. Or it's not going to count it at all. Okay, this is what they wanted. You can see the green check mark. If I was editing their textbook, it would not be saying that. If I want to change this verb to shrink instead of stretch, then by what factor did it shrink? It shrunk by a factor of 4. It's 4 times smaller. But they weren't thinking that. They're just thinking stretch is associated with factors bigger than 1 and shrink is associated with factors smaller than 1, which is probably fine. All right, now we have y equals 4x. The x value is getting modified. Okay. Draw a picture will help you reason out what's going on. So maybe here's my function, and I'd like to identify some behavior that's going on, let's say at 1. Now the y value needs to be the same on this guy. as it is right here. And the question is, will the transformed function behave, will it behave like this, or will it behave like this? Well, here's how you can reason it out. To get that same y value, would you put in a number like 4? Or would you put in a number like 1/4? It must be the 1/4. F of 4 times 1/4, that is f of 1, it will have the same y value. So evidently, to multiply by this number that's bigger than 1 makes this curve kind of taper. It's skinnier. All right. So again, we have some language issues here. Clearly it doesn't stretch horizontally by a factor of 4. I would technically be okay with this, but I know it's not what they want. In my mind, this is exactly what it should say. Oh, no, not vertically. It would shrink horizontally by a factor of 4, but they don't have that option here. So it must be the case that they're wanting this. It's a quarter as wide as it used to be. At any given y value, it's a quarter as wide as it used to be. We only have to go out in the x direction 1/4 as far to produce that same y value. Let's check it. All right, doing great. And then the 1/4 x, well, now it's easy to see. If I'm talking about f of 1, then f of 1/4 times something, for them to be the same y value, that something would have to be a 4. So it's going to stretch horizontally by a factor of 4. Okay. This says explain how the graph of G is obtained from the graph of F. Well, it's shifted to the left 2 units. Because that's really the only difference. In fact, I think we looked at this exact example earlier. At the start of all this. Or maybe I used 5, I don't remember. Now we have a modification of the y value. It shifts up. 2 units. You have a modification to the x values. You have a modification to the y values. So it's got to shift down by 4 units. So it won't be this one, it won't be this one, it won't be this one. It's got to shift down 4 units. Now you're just left between choosing, is it moving to the left or is it moving to the right? Well, you'd have to put a -4 right there in order to get a 0. So it must be shifting to the left by 4 units. And then they have you look at some pictures. Oh, look at that. It's the exact example I was talking about earlier. You can do that one. Oh, here's a nice one. X minus 5 squared plus 4. It's going to be a parabola. It's going to be 4 units above the x-axis. And that number right there is going to be 5. There's nothing else to it. It must go through the point 5, 4, because if I put a 5 right here for x, then it would say that f of 5 is 4. So it has to go through that point. It has that point for its vertex. And then the unshifted version would just be, right here. Absolute value of x, match it with the function. You can do that. It's just shifting to the left 3 units. In fact, this was it. X squared plus 2, that's moving it up by 2 units. Oh, you're not seeing what I'm seeing. Sorry. X minus 5 squared plus 1. It moves to the right 5 units. It moves up 1 unit. And this is transformations. No, not much to it. Here they have you write the equation. They want it shifted downward 5 units. X squared minus 5. There it is. Here they want it shifted to the left 3 units. It's going to be the square root of x minus 3. Or sorry, to the left 3 units, x plus 3. Because then when I put minus 3 in, which is 3 units to the left of 0, you get square root of 0. Shift this 4 units to the left. And then downward 6 units. Well, there's my down 6. And then 4 units to the left. There we are. Here we go. Reflect in the y-axis and shift upward 7 units. I can do the upward 7 units pretty easy. to get to the reflection in the y-axis, all we need to do is take all those y values and make them negative. Seeing if there's anything else here that's tricky looking. The graphs of f and g are given. Find a formula for the function g. Well, f is the blue one and g is the red one, obviously. So it's gonna have a reflection about the x-axis. So I can reflect about the x-axis like this with a minus square root of x. There, now it's reflected about the x-axis because I made all the y values the opposite sign. And now it needs to shift to the left by 8 units. There, when I put in the minus 8 for x, I get a y value of 0. And the rest of these look pretty simple. And that's it. Okay, so this is your video on transformations. Let me know if you have questions.